Hi, I'm Martin. Welcome to Groundhog Graphics. This is episode 5 of Programming in C. In this episode, I will demonstrate the do-while loop and the increment and decrement operators. Loops are probably the most important part of any programming language. The loop gives the program the ability to perform a single task millions of times. Sometimes the loop will be responsible for many tasks too. It all depends on what you put in your loop. As we have seen so far in our previous programs, all of them run through once and then exit. With the while loop and the do-while loop, we can have programs that never end if we don't want them to, or they can end if a certain condition is met. Once again, our relational operators and compound relational operators will be at the heart of this decision making. Alright, so let's begin by creating a new project. We will make it a console application. We will select C, project title, EP5. Next, and defaults are fine. And now I'm going to delete what CodeBlocks has put in here for us, as always. And now I'm going to pause the video and I'm going to write the program, and then we are going to come back to it and see it line by line with full explanation. So here is an example of a while loop. The while loop performs a conditional test in the parentheses following the keyword while. It works exactly the same as the if statements we have discussed in the previous videos. 0 is false and any other number evaluates true. Now this loop that we have here is what you would call an infinite loop. The condition that's being tested will never change, and thus it will never end. Enclosed in the curly braces beneath the while keyword is known as the body of the loop. Let's run it and see what happens. However, if you are not in a windowed environment like myself, you may be better off just watching my output rather than running this for yourself, since you might have to restart your computer to end the program. F9. And there it is. I will never stop. Ha ha ha. And it won't. It will just continue on. And the only way to stop it, if you're in DOS, you can hit Control C. That should break it. And if you're in another operating system, I'm not exactly sure. And I'm in Windows right now, so I will just use the X and I will close it. But you will see that we will terminate with an error. Process terminated with status, and it has this number right here. Normally it would terminate with 0 if it was successful termination, but the program was forcefully closed, and therefore we came out with this very large number right here indicating that something went wrong. So now I'm going to alter the program and we're going to make something a little bit more practical. So now I've added the integer and named it counter. I have assigned it the value of 10. I have replaced the 1 inside the parentheses next to the while keyword with our variable counter. Now I'm going to introduce to you the decrement operator. The decrement operator is a minus sign, two minus signs placed before or after a variable. This will cause our counter to subtract 1 by 1 every time the loop runs. Our loop will end when the counter equals 0. Let's see it in action. F9. Oh, there, F9 now. Okay. Now you can see that our counter started off at 10, but it doesn't display it because the decrement operator has already subtracted 1 before our printf occurred right here. See, counter minus minus, then our printf occurred after, so you won't see 10, but you can see that it counted from 10 down to 0 right here. Now let me show you a little trick we can do here. Oh, actually, you know what we could do? Let's change int to a character, char, and let's just make it 1. And now with our counter, let's go plus plus. Now this is the increment operator. Works as similar to the decrement operator, but this one, instead of subtracting 1, of course, it adds 1. Now what I've done here is by changing our variable from integer to character, I've changed the maximum value that counter can hold. The maximum value counter can hold now is 255. So counter will count up to 255, but then when it goes over, counter is going to equal 0, which will be a false, and we will be able to escape out of this while loop. This is just a quick sample for you, so let's just see what this does. There we go. Well, it's thinking that the character is a signed number, but that's okay. We haven't gotten into signed and unsigned values just yet, but it did do exactly what I said. It just doesn't look like it. Let me go ahead and fix it real quick. This is known as a modifier. Let's see, unsigned, which modifies our character counter and makes it an unsigned character. So all values will be positive. And let's rerun this. There we go. So you see that it kept adding numbers until it got to 255. Then after 255, it went and rolled over to 0. And then our while loop stopped. But notice here that our unsigned character counter, I assigned it the value 1. What happens if I assign it the value 0? And then I start our loop. Let's go ahead and go to F9. Well, it doesn't do anything. It doesn't do anything at all. Well, that's because counter equals 0, which is false. When while comes down here and it sees the counter is false, it never executes the code in the body of the loop. So how can we fix this? Well, we can fix this with what is called a do while loop. And let me show you what that is. Let me go ahead and I'll cut this out, Control X. And I'll place it here at the bottom, Control V. I'll place a semicolon after it. And now at the top, I'll put in do. Now what this does is this do guarantees that our loop will execute at least one time. And the while down here will keep continuing the loop until the counter equals 0. So now counter can equal 0 and we will at least get the beginning of the loop and it will continue on just like it did before. Let's go ahead and execute. And there it is, counter 255, and it works again. And that's the advantage of do. Do allows, or do guarantees that the loop will run at least one time before exiting. Now let me give you another example of what the increment, how it could also be written. So let's see here. We have counter plus plus. We know that it adds 1 to itself. But another way, and see this is a shorthand version. This would be the longhand version, would be counter equals itself plus 1. Now if I execute the code with F9, it does the same thing. But in C, and I think some other languages, you can use this little shorthand notation for counter plus plus, and it just does the incrementing for you, or decrementing. So that's a nice little shorthand feature in C. And we will get more into data type modifiers in a later episode. For right now, I want to focus mostly on our do while loop. So now I'm going to pause the video, and I believe I'm going to make us a little bit a more practical example for our while loop. And we're going to use, I think we're going to use the switch statement. So here is our more practical example of a loop using the switch statement. Before I explain the code, I want to run the program so you can get an idea of what it does first. This will help you understand the explanation of the code. F9. Oh, second here. F9. Okay, please enter an integer value. So what this program is a simple calculator. I'm going to enter two numbers, and then I'm going to perform some mathematical operation on them. So let's go ahead and enter 30, and for my second number, 20. Please choose one of the following options. So in this calculator, I can add, subtract, and multiply. I decided to take out divide because divide I would have to use a float data type, and it would have added some complexity to the code, and I didn't want it to take away from our lesson on do while loops. So let's go ahead and make a choice. We'll go ahead and add. 30 plus 20 equals 50. Do you wish to continue? Yes. Why? So now you notice in this program we have not had to close and restart like we have in all of our previous programs because we're using a do while loop. Let me go ahead and put another number. Let's see, 10 and 20. Now let's do 10, 25. And let's go ahead and 2, we'll subtract it. 10 minus 25 equals negative 15. No, that's right. Let's see, let's do another one. Enter an integer value, 50. And let's do 50. In this case, let me enter something outside of our menu option. Let's go with 5. You must enter a valid option. So now it's polling me again to enter from our menu options. So let me enter 6. Oh, you must enter a valid option. So it won't let me do anything. Let me enter 0. Nope, won't let me do anything until I select one of our menu options, and I'm going to select multiply, 3. And 50 times 50 equals 2500. That's correct. The loop is iterated 3 times. I left the counter in our loop so we can just count how many iterations. Do you wish to continue? No, I think I'm good. Have a nice day. Yeah, great. Now back to the code. So in this example program, I am using 2 do while loops and 1 while loop. I have also made many remarks in the code to help us understand what each part does. Let's start near the top and work our way down. First, I have declared several variables. We still have a counter to count the number of times our loop iterates. I've added KBI, which stands for keyboard input. I am using X and Y to take inputs from the user, which will be 2 numbers that the user will perform some mathematical operation on. Then the result of the math operation will be stored in the variable named result. Lastly, I have created a character variable named op, short for operation. The program will use this variable to assign the appropriate symbol for the math operation that the user chooses. This will then be printed out in the printf statement below. Now we begin with a do while loop for pretty much most of the code in our program. This is the main program loop, and it also, and it allows the user to do as many math operations as they want without having to restart the program each time. We use 2 scanfs to get both numbers that the math operation will be used on. Notice I have used a getC after the second scanf to clear the enter key from the keyboard. I didn't need to use it for the first scanf because, well, it didn't seem to interfere, so I left it out. Next, we have several put strings to output a menu to the screen, so the user can decide what they want to do with the numbers they have entered. Now I present the second do while loop. This is known as a nested loop because it resides inside of an outer loop, which is our main body loop. This loop will take the input from the user and ensure that the user has entered a valid menu option. If they haven't, then the default case in our switch statement will inform them the choice is not valid, and the do while loop will continue looping until the user has entered a valid menu option. Here now is our last while loop. This one looks a bit different than what we have seen before. This one doesn't even have a loop body. The purpose of this loop is to remove all the keys that may still remain in the keyboard buffer. I noticed when I wrote the program that if I were to enter the wrong menu option, such as 2 letters like EE, and hit enter, it would throw the entire loop out of whack, because the second E in the keyboard buffer would then be accepted as input in the following call to getC. My only choice was to clear the keyboard buffer completely, so the following calls to getC would perform as expected. That way the user couldn't enter, 2 letters or 3 letters and then end up kind of screwing the whole program up. I didn't want that, so that's how we clear it out and make sure that can't happen. There is, however, a better way to clear the keyboard buffer in C, but this gave me an opportunity to show you another example of a loop. In time, as we advance through these tutorials, I will show you all the better ways to do stuff, but for now, let's focus on the topic at hand. Something else we need to take notice of. Inside this while loop, we are making a call to get C. This is another nice feature of C. C allows us to create compound statements. We can call functions and send their return values directly as parameters to other functions, or even test the return value immediately against a value without using a variable. Let me explain how the flow works here. The while begins, then get C is called, which effectively pulls one key press from the keyboard buffer. We then compare the result of get C to the value of 10, which is line feed in the ASCII table, which really just equates to our enter key or return key. So what this does is loops repeatedly, pulling all the characters out of the keyboard buffer until the return value of get C equals the enter key. This should effectively clear the keyboard buffer, so we know the next get C will not be working with any kind of erroneous data. We don't even have to assign the value of get C in this case to a variable because the value is instantly compared to 10. However, if we had any need to use the return value of get C in another program, or another part of our program, we would have to use a variable because this value in its current state will just be discarded after each run of this while loop, since it's not being stored in memory. Now let's dissect the switch statement. Each of our cases inside of the switch perform a math operation that is available to the user. Let's look at case 1. This will perform addition. The first statement reads, result is equal to x plus y. Remember, the user entered two numbers, and both of those numbers are stored in the variables x and y. Then immediately following that, the char variable op gets assigned the plus symbol, so later when we print the result of the math operation, it will show the plus symbol in the printf output. Notice all the following cases assign op the appropriate symbol for the math operation that was chosen. And then we see the default, which tells the user to enter a valid option. Only if the user enters a value that is not equal to one of our cases above will this default execute, much like the else statement much like else in an if statement. Now we have reached the bottom of our nested do while loop. The while in this case is testing that input received from the user is within the range of our menu options. Specifically, it is checking to see if KBI, keyboard input, is less than 1 or greater than 3. Being that all numbers and letters received from the keyboard are received as ASCII codes, and all ASCII codes are numbered in order, we can check to see if the number is correct, or the input is correct, by comparing against their ASCII codes. Now, the thing is that right now we're using a single quotation mark to represent the actual character. But like I said before, when C comes through, it's going to replace that with the actual ASCII code. But you know what? Let me clarify this. Let me show you a small example or a small sample of the ASCII table. So here's the ASCII table for numbers 0 through 4. From the table, we see that character 1 in our menu option equals the value 49. And the character 3, which is our last menu option, equals 51. So if we test to see if the value entered by the user is less than the ASCII code, 49, or if the ASCII code is greater than 51, then one of the relational operators will return true, which will make our do while loop continue looping. Let's see if what I have said is actually true. I will replace the number 1 with and number 3 with their respective ASCII codes and then rerun the program. So let's go right here. Less than 49 or greater than 51. Now let's run it and see if this works, and it should work exactly the same. So F9, please enter a value 30, 40, and now I'm going to enter any key outside of a range 7. Now you must enter a valid option. Okay, what about 4? Oh, I got it. Nope, that doesn't work. How about 0? Nope. Okay, well let's go ahead and subtract it. 2. Then it works. Do you wish to continue? No. Have a nice day. Thank you. So, as you can see, right here where I've entered the ASCII code 49, or keyboard input is greater than 51, it is actually comparing the literal ASCII code from the keyboard input. But you know what? When you're going through a program and you're reading the source code, how do you don't know what 4951, what is that? Now I have to go look up the ASCII code? No. Nobody wants to do that. So we just put our single quotation marks and we put our 1 back in here. And we put our 3 back in here. And now we can see it makes much more sense this way. Okay, so now we have the printf statement. %d, %c, %d equals %d, and that is saying those are going to be the placeholders. So x, and then the op, which will represent either an addition, subtraction, or multiplication, and then it will be printing the value of y. So it'll be like x plus y or x minus y. That way we can have one printf statement to print for all of these different possible mathematical operations, and then it will print result. So that's what prints our final result for the user. Then we have counter plus plus, that increments our counter, so we know how many times we've iterated our loop. And the printf here, the loop is iterated %d number of times, so we have our counter there. And then we have put string, do you wish to continue? Please answer yes or no. We accept our keyboard input. Again, we use KBI, and get C for our standard input. That discards our carriage return from the keyboard buffer. And you see we have our little remark right here. Now here is our final program, our main body loop for our program, and it will be testing to see if the keyboard input is equal to lowercase y, or with 2 vertical bars, keyboard input is equal to a capital Y. And if it is equal to either one of those, then the return result from the relational operator will be true, and our main program loop will come back all the way up to the top where do is, and it will start over again. And if it is false, which would be any other key, you don't actually have to enter n, because we're not really checking for n here, then it just tells you have a nice day. So this concludes our video on do-while loops. I hope it was educational. Thank you very much for watching, and I will catch you in the next video. Thanks a lot. Bye.